Now that you guys have learned how to convert between grams, moles, molecules, atoms, and formula units, what we're now going to do is learn how to actually create these formulas that you guys have been writing, the formulas for these compounds. So how exactly did scientists figure out these formulas for these compounds? And they did so experimentally. And so there are two different terms that you need to learn in order to be able to talk about these formulas. The first one is empirical formula. So the empirical formula is the lowest whole number ratio of atoms in a compound. And so we'll look at some examples in just 1 second. While that's the empirical formula, the molecular formula is actually what you've already been working with. It's the actual formula of a compound. So if we look at this example here, if you look at C2H2, the question asks you to identify any empirical formulas. Well, C2H2 is not the lowest whole number ratio, and therefore it is not the empirical formula. It is a molecular formula. C2H4 again is not the lowest whole number ratio because you can simplify that to CH2. So that would not be an empirical formula. C2H6 can be reduced to CH3, so again, not an empirical formula. C2H3O2, we can't actually reduce that, so that would be an empirical formula. And then finally, C4H6O4 can be reduced to C2H3O2 by dividing by 2, and therefore it's not an empirical formula, it's a molecular formula. So how exactly do I get the empirical formula? How can I create, for example, C2H3O2? Well, you would do so experimentally. So if you were to take 2.5 gram sample of a compound and you were to discover that 0.900 grams of it's calcium and 1.60 grams of it is chlorine, you can actually determine the empirical formula. So what we're going to do, the subscripts for all of these molecules, they are actually the number of moles. So all we need to do is the following. We're going to take the number of grams of each of these elements, so calcium to start with, and we're going to convert it to moles. So I'm going to crisscross swoosh. I'm going to put grams on bottom and moles up top. Okay, I'm going to put the molar mass of calcium on bottom and 1 on top for moles. Okay, so I'm going to divide, and what I get is 0.0224456 moles. Awesome. I'm going to do the exact same thing now for chlorine. So if I start with 1.60 grams of chlorine, crisscross swish, grams on bottom, moles up top, okay? I'm going to put the molar mass of chlorine on bottom, which is 35.453, and then 1 in front of moles, and what I get when I divide is 0.04513 moles. So the formula would look like this. It would be calcium with the subscript 0.022456, chlorine with the subscript 0.04513. Now, that's not actually what you see when you look at a formula. You don't have tiny numbers like that. Well, what we have to keep in mind is that we can actually reduce this. And so what you're going to do now, your final step, is you are going to divide by your smallest number of moles, which in this case is going to be the 0.022. So I'm going to divide both of these by 0.022456. And what I end up getting is calcium, there'd just be 1, so calcium 1, and then Cl, if you divide, you get 2. Okay? If it's 1.9, you can round that to 2. If it's 2.01, you can round that to 2, that's fine. As soon as you get greater than a tenth off of a whole number, so for example, if I had 2.1 or 2.2, you cannot round. So we're going to have instances where you'll have 1.5. So for example, in this problem, if I had CaCl 1.5, I cannot round that to 2. So what you need to do in that case is take both of those subscripts, the 1, the implied 1, and the 1.5, and multiply them by 2. So you would get 2 for the subscript for calcium and 3 for the subscript for chlorine. But in this case, it actually worked out nicely. You got almost exactly 2, and so there is your empirical formula, CaCl2. Okay? Let's try one more example. What if instead of masses, I gave you percents? Well, it might seem a little bit intimidating until you realize that what I can say is, all right, the total mass of my sample is 100 grams. If the total mass of my sample were 100 grams, then I would have 79.8 grams of carbon and 20.2 grams of hydrogen. So that's exactly what I'm going to do. And then it's the exact same thing as the previous problem. So I'm going to go from grams of carbon into moles of carbon by dividing by the molar mass of carbon, and I get 6.6439 moles. Then I'm going to take 20.2 grams of hydrogen, same thing, use the molar mass of hydrogen, and I get 20.03968 moles. Okay, I'm going to write this as C subscript 6.6439, H subscript 20.03968. My last step, again, is to divide by my smallest number of moles, which is 6.6439. And what I get is C, 1, but I'm not going to put the 1, H, 3. And I'm done, because the value that I got by dividing the 20 by the 6 was extremely close to 3. I think it was like 2.99 or 3.01, so I could round it to 3.